In the last session, we have learned about gravitational force. Let us have a little recap on that. We have learned about Earth's gravitational force. Earth's gravitational force. According to Newton's law of gravitation, every mass in the universe attracts another mass with a definite force, and that force F is given as G m1 f2 upon r square. This is what is the Newton's universal law of gravitation. G is the universal constant. This is what we have learned. हे आपण शिकलेलो आहे आणि त्याप्रमाणे we have learned that if this is Earth center, right? This is the Earth center. And Earth's mass, let us say capital M आहे. M is the mass of Earth, capital M. And if there is an object here, this is having mass M, this radius of the Earth is capital R, then there will be a force towards the Earth, and this is called as the Earth's gravitational force. आणि ही आपण काल म्हणण्यापेक्षा लास्ट सेशन मध्ये आपण कॅल्क्युलेट केली आहे. This force is nothing but this one, right? Actually, this is at height h from the surface of the Earth. So this is at height of h. So the distance r, this is equal to r plus h. But we have studied last time, this h is very, very small compared to the radius of the Earth. So we are considering r is equal to. So any object, whether it's in the space or it's near to the Earth's surface, or let us say it's on the surface of the Earth, this will experience a force, and that force is called as gravitational force. Gravitational force. But you are learning 9th standard. 9th standard means तुम्ही काय शिकलाय? If there is a force on any object, then the object will experience an acceleration. This is Newton's second law of motion. Newton's second law of motion. So I can write down here, according to Newton's second law of motion, and if an object is subjected to an external force, it undergoes an acceleration. तुमच्या मनात एक प्रश्न पडला असेल की न्यूटनचा सेकंड लॉ प्रत्येक वेगवेगळ्या प्रकारे का लिहिला जातो? न्यूटनचा सेकंड लॉ 11th मध्ये जेव्हा तुम्ही शिकणार ना, you will learn in a different way. The rate of change of momentum is called as force. In 9th you will learn as F is equal to ma. And now I am telling you, if there is an external force, there will be an acceleration. सगळ्याचा अर्थ एकच आहे. What do you mean by acceleration? What do you mean by acceleration? Acceleration is nothing but change in state of motion. State of motion. Rest. An object is at rest. He motion मोशनची एक स्टेट आहे का? Yes, it is a object at rest. म्हणजे काय? V is equal to 0. म्हणजेच V is equal to 0. So rest also is a state of motion, but the velocity is 0. So if there is a force, then it will change its state of motion. So that is the second law of Newton's motion. Newton's motion's law, second law काय सांगतो? If there is a force, there is going to be an acceleration. An object moving with velocity, it will increase the velocity. If the force in opposite direction, it will decrease the velocity. If the object is at rest, it will come into the motion. If an object is moving, it can change its direction because of force. And changing direction is also an acceleration. So, acceleration. आणि दुसरा पॉइंट काय आहे? The direction of acceleration is in the direction of force applied. So these are the two important things that Newton's law of motion says. If an object is subjected to force, it will experience acceleration. Acceleration is a vector quantity. Acceleration is a vector quantity. So this requires direction. And the direction of acceleration is in the direction of force applied. That means, suppose this is an object M. If you apply a force here, it will experience an acceleration. So if this is horizontal, this is also the horizontal. Direction of F and A will be same. Since there is a force on mass, there will be acceleration, and this acceleration is given up is equal to force upon M. M is the direction of force. So this is the relationship between force and mass. So this is an object. Another term is here external force, not internal force, external force. External force, right? So acceleration is given by F by M. So naturally, if we apply this Newton's second law of motion to the force of gravitation of Earth, then this gravitational force which the Earth is applying on the object also must produce acceleration in the mass. Is it not? Because this mass object is also experiencing force because of Earth, so naturally this mass also must experience an acceleration. So we can write down, हे लिहून घ्या व्यवस्थित. So I can write down. So I can write down here. Due to Earth's gravitational force, any object experiences an acceleration. Why so? Because according to Newton's second law of motion. This is according to Newton's second law of motion. Right? So what is the amount of that acceleration? So पहिली गोष्ट. So this law says F is equal to ma, or acceleration is equal to F by m, or you can say F is equal to ma, both are same. This acceleration, when it's provided by Earth, right, this acceleration is denoted as g, small g is denoted as g, right? हे G केव्हा आपण डिनोट करणार? When the acceleration is due to the force applied by earth. When the force is applied by the earth, then the acceleration produced is denoted by G. So we can say acceleration produced by earth's gravitational force is denoted as G. Is denoted as G instead of A. Normally we denote with A, but in this case we denote as G. So whenever you write G, that means this is an acceleration because of Earth's gravitational force on the object, and that is directed towards the center of the Earth. So that it's directed Earth G, and this acceleration is directed towards the center of Earth. So this is important. This is important. According to second law, if there is a force, there will be acceleration. So naturally, the gravitational force exerted by the Earth also will produce an acceleration in any object. And that acceleration is given by the formula A is equal to F by M. That is Newton's second law of motion. But instead of A, it is denoted by G since it is by Earth. And the direction of acceleration is towards center of the Earth. Towards the center of the Earth. So let us calculate. Calculations of G. Value of G. Let us calculate. So हे थोडं मी इथं रफ करतो. हे वेळोवेळी लिहून घेत जावा. पॉज करत जावा व्हिडिओ आणि लिहून घेत जावा. कधी कधी मी सांगायला राहून जाईल. So here the acceleration, so I can write down, so F is equal to M into G now. So this is second law of motion. Second NLM. I can say Newton's law of motion. And F is what? F is Earth's gravitational force. Earth's gravitational force. This is given by Newton's universal law of gravitation. This is given by Newton's law of motion. दोन्ही law Newton ने दिलेला आहे. This is given as G. Now here mass of M I am saying here, so I write down here M is equal to mass of Earth, and that value is given as 6 into 10 raised to 24 kg. That is the mass of the, so Gm. M is the mass of object. So M is equal to mass of object. So M is mass of object, and F is equal to R square. This H we are neglecting, so R is equal to R. And what is R? So R is equal to radius of Earth, and that is equal to 6.4 into 10 raised to 5 meters. It is actually 6,400 kilometers. Roughly, it is a little lesser than that. So this is the formula. So this is, I can say 1, and this is, I can say 2. So I can equate 1 and 2. So equating 1 and 2, we get. So M into G is G into capital M into small m upon R square. So m को मार दिया. So we got the value of G, that is the gravitational acceleration, G into m mass of Earth upon R square. So this G, gravitational acceleration, we are saying R, radius of Earth. He H G आहे. H is the distance of object from the surface. Surface वर जर object असेल, तर this R will be exactly R. Surface वर H at height H, this R will be R plus H. परंतु we are considering H as very small, as I told you in the last section. So we are neglecting this H. So we are saying this is almost on the surface of the Earth. This is what we can say on surface of Earth. On surface of Earth. Because this is R value, right? Or close to surface of Earth. So from this, it is clear. It is clear. So what is clear from that? So it is clear that the gravitational acceleration depends on G is anyway constant. G is a constant. This acceleration depends upon mass of the Earth and radius of the Earth. So we can conclusion what we can draw. So we can say the gravitational acceleration depends on mass of Earth and radius of Earth. So this is the important statement. It does not depend on anything else. It only depends upon R. Only M and R. Only M and R. Nothing more than M and R. म्हणजे मास आणि रेडियसच्या व्यतिरिक्त दुसऱ्या कुठल्याही प्रॉपर्टीवर G अवलंबून नाही. Let us say Earth's temperature वाढलं. Earth temperature increases from present 37 degree, 36 degree to 40 degrees, 50 degrees permanently. Whether the G will change? No, because in the equation there is no relationship with temperature. So the D does not depend upon the temperature. The G only depends on mass of the Earth and radius of the Earth. And you can see from here, if the radius is smaller, the lesser the radius, higher the G. More the mass, higher the G. And higher the G, more the force. If the force is more, if G, this is nothing but G. If the G is more, the force is more. Force of attraction. This is the force of attraction will be more if the G is more. G is high when the mass is more and radius is smaller. That means if you have a planet, just imagine, if you have a planet which is a big in mass and smaller in radius, that means compact, the high density, what we call, high density. You know density. Density is equal to mass upon volume. Suppose if you take sphere, then mass upon volume, sphere the volume 4 by 3 pi r cube. So this is the density. ज्या प्लॅनेटची डेन्सिटी जास्त आहे त्याचा ग्रॅव्हिटेशनल ऍक्सिलरेशन विल बी हायर, बिकॉज डेन्सिटी जास्त म्हणजे मोर मास लेस व्हॉल्यूम. ट्राय टू अंडरस्टँड. मोर द डेन्सिटी, जड, जेवढा प्लॅनेट जड हेवी तेवढा ह्याचा जी वाढणार. हा जी काय होणार? वाढणार. आणि हा जर जी वाढला तर m into g वाढणार, म्हणजे फोर्स ऑफ अट्रॅक्शन विल बी मोर. कुछ समझ में आ रहा है ना? So this g depends upon directly proportional to the mass of the and inversely proportional to the square of the radius. And this g, what about this g? What about this g? G is equal to 6.673 into 10 raised to minus 11 Newton meter square divided by kg square. This is universal. Newton's universal constant of gravitation is constant throughout the universe. Throughout the universe. So this will not change. If you go on moon, whether this value will change? Yes, because mass of moon will be different. Radius of the moon will be different. So the gravitational acceleration of the moon will be different. And that is 1/6 of Earth. That we'll study later. But just for information, it is a 1/6. It is a 1/6 of Earth. If the gravitational acceleration is low, that means the force applied by the planet will be low. More the G, more the force it will attract. Sum up, if this G is doubled, hypothetical. His G value double is the kind. If this value of G is doubled, then the G, the acceleration because of gravity, will be also doubled. So if G is doubled, this acceleration will be doubled. If mass is doubled, acceleration will be doubled. Two times. So mass is doubled, acceleration will be doubled. If R is doubled, then acceleration will what? Increase, decrease, remain same, 1/2, 1/4, what is that? If R is doubled, it's inversely proportional to 1 upon R square. म्हणजे G ची व्हॅल्यू कमी होणार, R स्क्वेअर ने कमी होणार, so G ची व्हॅल्यू 1/4 होणार. G ची व्हॅल्यू 1/4 होईल. सो याच्यावर न्यूमेरिकल्स खूप विचारले जातात. 11, 12 मध्ये खूप इम्पॉर्टन्स आहे. So G is equal to Gm upon R square. Sums up. If there is no gravity, म्हणजे हा gravity ने mass नहीं है. So what will happen? If there is no gravity, then the G will be equal to 0. So naturally, there won't be any force of attraction. So if you can write it down, we'll calculate the value of gravitational acceleration. So we can calculate the value of G simply by putting the values. So gravitational acceleration, that is denoted by G. This value of G is equal to 6.673 into 10 raised to minus 11 into mass of Earth, that is equal to 6 into 10 raised to 24 m divided by R square, and that is equal to 6.4 into 10 raised to 5 whole bracket square. 6.4 5 whole bracket square. So if you calculate this value, you will get G is equal to 9.77. What is the unit of this one? What is the unit? So unit of G is same of unit of G is same as A. Current G काय आहे? G is the acceleration. So there is nothing. It's the same. Only for the A ठिकाणी G म्हटले because it's the acceleration because of Earth. That is the only reason why it's a G, and the unit is same. So this unit we can call meter per second square. So this is the value of G. So this value of G depends upon mass of Earth and radius of the Earth. This value of G. This gravitational acceleration on any other planet will also depend upon M and R. So if you know the mass and radius of any other planet, you can calculate the gravitational acceleration of the planet. This G will apply a force on any object, and that force is equal to, let us say this is the earth here and there is an object here. This is a mass m, so this is a gravitational acceleration G, so this will apply a force m into G, right? And this mass will fall down on earth, and when it falls down on earth, what will be its velocity? Let's say u is the initial velocity. When it reaches to the earth, its velocity will be the final velocity is equal to v. Then according to Newton's laws of motion, we know v is equal to u plus at. Second, we know v square is equal to u square plus twice. आता या ठिकाणी काय होणार आहे? a च्या ठिकाणी काय acceleration? What is acceleration? So acceleration is not a but it's the g, because आपण a ला g म्हणतो, and it's twice g into s, where s is the distance here to here. S is twice gs. And third equation, you know that s is equal to ut plus 1 half a च्या ठिकाणी gt square. So the force is equal to mg. Because of this force, there will be acceleration g. Initial velocity, you can say u, or you can say u is equal to initial velocity. So this is the initial velocity, and v is equal to, I can say, final velocity. So from here, I don't know whether you can see this value s. I'll write down here. So this is the s. S is the height. So applying Newton's kinematic equations, you can calculate v, time, then distance, everything you can calculate. More the g, more the force. More the g, more the force. More the g, more the velocity. More the g, more the velocity. Distance traveled, more the g, more the distance traveled. If the g is more, then the force acting on the object will be more. Just imagine. Just imagine. Just imagine. Just imagine. This is the earth here, this is the moon here. This is the earth here, this is the moon here. If you drop a stone from here on the earth, it will attract with some acceleration, and the force will be mg. Here also, if you drop the same mass, same stone from some height, moon also will attract, but the acceleration of moon is 1/6, 1/6. So acceleration, so g of moon is equal to 1/6 of g of earth. That means if it is 9.8, then this is 1/6 of. So for example, I can write down g moon म्हणजे काय आहे? What is this g moon? G moon acceleration, gravitational acceleration of moon. Gravitational acceleration of moon. So g moon is equal to 1/6 into 9.8. So you can calculate 6 ones are 6, 3, 38, 6, 6 are 36, 2. So 1.63 meter per second square. That is the gravitational acceleration on the moon. If you know mass of the moon, radius of the moon, we can get the same value because g is constant everywhere. G is constant. So if the g is less, this force will be less. If the mass is 1 kg, let us say the mass is 1 kg. If the mass is 1 kg, how much is the force? 1 into 9.8. So here the force will be 9.8 Newton. Here the force will be m into g moon. M is mass is 1 into 1.63. Force will be 1.63. So if you drop a stone on the moon, it will take longer time to reach on the surface of the moon, and The same theory is applied to black holes. If you study black holes, if anything comes close to black hole, it attracts everything. Because black hole, huge mass, small radius. Huge mass, small radius. Whatever comes into contact, zoom, zoom, it will get catch into. So that is a black hole. Go to Google, search on black hole and learn the things. So G moon, G earth, now you are able to understand the terms. Going further, whether this gravitational acceleration is constant, whether this is a constant, I can only say this G depends on mass and radius of earth. I can only say it depends upon mass and radius of earth. If mass of earth changes, then this G will change. If mass of radius changes, this G also will change. So is the G changing on earth? Whether the G is constant on the earth? तुम्हाला असं वाटलं की G constant आहे, earth radius constant आहे, mass constant आहे, so G constant. Yes, म्हणजे तसं बघितलं तर constant म्हणता येईल आपल्याला. पण G is not constant on the earth. It is different on equator, it is different on pole, it is different, the G different at certain height, and G is different if you go inside the earth. समजा अर्थ आहे, अर्थ like होल मारले, बोर एक मोठं बोर मारले, 1 kilometer, 2 kilometer, 10 kilometer, अर्थ रेडियस आहे 6400, 1000 किलोमीटर सारी होल मारले, 1000 kilometer. G will be same here, but it will be different. So that effect of G, or effect of these other parameters, the effect of M and G, M and R, that we are going to learn